Hello everyone, welcome back, and today we are looking at question 48, which is rotate image. So this is a medium problem, and honestly it's a bit tricky, but as always we will make these tricky things simplified. So we are given an n by n 2D matrix, which means the matrix is a square matrix, and it represents an image. We want to rotate that image by 90 degrees clockwise. Imagine yourself holding this 2D matrix with your hand and you are rotating your hand to the right. Now they are saying that we must do everything in place. As you can see, the return type is void, which means we cannot create a new 2D array and copy elements to it, then we can return it. No, everything must be in place, which is fine. So as always, we will go to the blackboard, we will explain the approach, then we will code the solution out. Here we are at the blackboard, and as you can see I have drawn a 2D matrix holding the elements 1 through 9. And also I have put the indices of the rows and the columns. As you can see we have 3 rows and 3 columns, 0, 1, 2, 0, 1, 2. Okay, so we want to rotate this 2D matrix by 90 degrees clockwise. Sometimes, you know, in the interview, when you find a question like this, maybe the question is a little bit tricky and you're not sure what to do. Just sometimes people panic and they put their hands on the keyboard and they start typing the for loops and they don't know what to put inside of them. Now, in situations like this, what I like to do is I like to stop, I like to step back, and I like to think before I type anything. Now, let's think about this. Let's look at this problem from above. We don't want to go straight into the smallest details and to see, hey, okay, if I rotate this, where this one will be, where this two will be, I don't know, I'm confused. No, step by step. Okay, so let's do that. Let me take this and rotate it in front of you and let's observe. Okay, here it is, and let's rotate to the right by 90 degrees. Think about this. I want you to think what would happen, what these rows and columns will look like. So 1, 2, 3, let's rotate it. Okay, here we have the rotated image of the 2D matrix. What do we observe? There are two really important things that we need to see. One, let's look at the columns of the original matrix. We see the 1, 4, 7. You see this? We can see it right here. The 1, 4, 7. Okay, look at this, 2, 5, 8. We can see it right here. 2, 5, 8. 3, 6, 9. Look, we can see it here. 3, 6, 9. I know the numbers looks funny, but it's on purpose. Everything you see is on purpose. Just bear with me. Okay, so as you can see, each column was transformed into a row. The first column became the first row. The second column became the second row, and the third column became the third row. So this is important. So we observe that the rows and the columns got flipped. They got switched. Okay, what else do we notice? The indices of the rows stayed the same. 0, 1, 2, 0, 1, 2. But look at the columns. The indices were 0, 1, 2. Look now, what do we have? Hey, we have 2, 1, 0. So originally it was 0, 1, 2. When we rotated it, the indices of the rows became 2, 1, 0. They got reversed. As you can see, step 1, the rows and the column got switched. Number 2, the rows got reversed. So the rows reversed. Okay, as you can see this, just by observing the situation, looking at the problem from above, we just know how to solve the problem. 1, we need to switch the rows and the columns. After we switch them, we need to reverse all the rows, and we will get the answer. Now, in the world of linear algebra and matrices, when you say you want to flip or you want to switch the rows with the columns, this whole operation is called transpose the matrix. You see? Transpose the matrix. When you hear this word, this simply means, hey, I want to switch the rows with the columns. Now, how can we switch the rows with the columns? You see, we have a 2D matrix. Each number in the 2D matrix is represented by rows and columns. Here is I, here's j. Now, when we want to flip the rows and the columns, simply we switch these, right? So each number is I and j will be transformed to j and I. This is the general approach, the overview. Now at least we know what to do, where to start. The problem is divided into two steps. One, we need to switch rows and column, which means transpose, which means each element flip the I and the j. Once we finish that, we will go to step 2. Hey, go to each row and reverse it, and we will get the answer. So now let's go into each one of those steps in details. Okay, so let's start with the transposing the matrix. Now I know we have to do everything in place, but before we do that, I want to make sure we understand the idea. Then we will slightly modify the code to make it in place. It will be like literally slight adjustment. I don't want to be all over the place. Let's take it step by step. Now let's try to transpose the matrix. Okay, we said for each element we want to flip the I with the j. Looking at the 1. The 1 is in row 0, column 0. Flip the I and the j, the 0, 0 will be 0, 0. So here's the 1. Let's go to the 2. The 2 is at 0, 1. Row 0, column 1. Okay, this will become at row 1, column 0. Let's go to row 1, column 0. Here is the 2. Now going to 3, the 3 is at row 0, column 2, which means that it will become at row 2, column 0. So here is the 3. Now we will go to the next row. So we have the 4. Where is the 4? The 4 is at row 1, column 0, which means that the 4 will become to what? 0, 1. We will go to row 0, column 1, and we have the 4. Okay, go to 5, the same thing. 5 is at 1, 1. Flip it, it will also become 1, 1. So we have the 5. In other words, all this 1, 5, 9, the diagonal, this will stay the same. So we'll also have 9 here. Because, as again, 2, 2 will be flipped to 2, 2. But now, let's go to the 6. The 6 is at 1, 2. Flip the 1 and the 2, we will have 2, 1. Go to row 2, column 1, boom, we have the 6. We have now the 7. The 7 is at row 2, column 0. Flip, it will become at 0, 2. Let's go to row 0, column 2. We have the 7. And finally, let's go to the 8. The 8 is at row 2, column 1. Flip, it will go to 1, 2. So let's go. Here we have row 1. Here we have column 2. Here we have the 8. Okay, let's check if it worked. We have the column 147. Here it is. It became the row 147. The second column 258 became the second row 258. 369 became 369. So let's compare with the answer to the matrix. As you can see, we have 147. Here they have 147 in the reverse order, right? So 258. Here they have 852, 369, 963, and that's why we said we need to reverse the rows. But before we reverse the rows, I would like to code the transpose section first, and let's see how can we do that. One, we said we want to do everything in place, so let's focus on this. We said we will go to the 1, and the 1 will stay at its position. 0, 0 will stay at 0, 0. Now when we go to the 2, we will take this 2. This 2 is at row 0, column 1. It will become at row 1, column 0. We go to row 1, column 0. We see we have a 4. Now, if we remove this 4 and we put the 2, hey, the computer will be like, oh my god, I lost the 4. I don't know what to do. I forgot what was here. It's our job to make sure we don't lose anything. So here we had a 4. We need to keep it, right? We will create a temp variable to hold the element that we remove. Here we are putting the 2 instead of the 4. We don't want to lose the 4, so we put it into a temp variable. Hey, this temp will hold the value 4. So now when we remove the 4 and we put 2 instead of it, we know that the 4 is saved somewhere and we will not lose it. And this is the only adjustment that we need to make. For each number we remove, we have to make sure it's saved in a temp variable, okay? Now this is step 1. Now step 2, what? Well, we said we want to switch the rows and the columns, and we want to loop through the elements of the 2D array. So we will have a nested for loop, the normal stuff for, int I equals 0, and we say I is less than the number of rows, and we say, okay, I plus plus. And now when we go to the second for loop, what we normally do, we say, hey, for int j equals 0, j is less than, the number of columns, and we say j plus plus. Then we start the logic. But there's a problem here. What is that? Let's see. Imagine we are starting here. We go to the 1, okay, for int I equals 0 means that we are on the row 0, and we want to loop through all of it. So we know I is 0. Okay, now we start at the j. J is 0, which means we are at 1, we take care of it, we go to 2, we take care of it, we go to 3, we take care of it. Now we will go to I equals 1. Now we are here. Now what happens? We say, hey, for int j equals 0, we are starting again here. But what do you notice? We already took care of this switch. We had, as you remember, we had a 4 here, and we switched it with a 2, right? So we already switched the 2 and the 4. But now when we go again here and we say for int j equals 0, and we try to switch it again, we will switch, and what do we see? We came back to square one. We did not do anything. We undid what we did. Like we just click the undo button. We don't want that. We want to skip this section. This section is already done. We already said, hey, here we have the 2 and the 4. I don't want to start for int j equals 0. But what I want to do, I want to start from int j equals to I. We know that I is 1, and when we say j is 1, means that we will start here. We will skip this because it's already done, and we start here. Now we finish the 5. When we flip the 5 with the 5, it stayed here. And of course, when we finish this row, we would have already switched the 3 and the 7, of course. So we have the 7 and 3. But now we are in this row. 5 is flipped with 5. 6 will be flipped with 8. And we finish this row. Now I equals to 2. And we said for int j equals I. If we don't have this, and we said for int j equals 0, we will go to 3, we will undo what we did with 3, then we will go to 6, we undo what we did with the 6, then we go to 9. No, I want to skip this, and I want to skip this. I want to go straight to the 9, because we already finished the 3 and the 6. Now when we say for int j equals I, we know that I is equals to 2, now j is equals to 2, and what do you see? 0, 1, 2, now we go straight to the 9. This way, we will not undo anything. So let's go write the code for the transpose function, and 2 main things in the transpose function. 1, we need to make a temp variable, and 2, in the inner for loop, the j must be equal to I. So let's go and write the code for that, okay? We said we need to transpose the matrix, so transpose the matrix, and we said we need 2 for loops, so for int I is equals to 0, I is less than the number of rows, but we said the number of rows and the number of columns are the same, so we can make a variable for that. So int, I don't know, int length, for instance, equals matrix.length. Usually we use the matrix.length to have the number of rows, but again, the number of rows and columns are the same since we have a square matrix. Okay, so for int I equals 0, I is less than length, I plus plus, and now we go to the inner for loop. Again, we said we need to make the j start at I, so we do not undo anything. So for int j equals to I, we just explained why, j is less than length, then we continue normally, j plus plus. Then the logic starts. Imagine we are here at the 1. The 1 will be, 1 switch with 1, no problem. But when we go to the 2, we will take this 2, right? And we want to put 4 inside of it. We want to flip these 2. The 2 will become 4, the 4 will become 2. I do not want to lose this 2. So what do? We make a temp variable, int temp equals matrix of I and j Imagine that I is 0, j is 1, which means this 2. We put this 2 in a temp variable. Then I don't care what happens to this 2. Matrix of I and j. I want to change this 2 with matrix of ji. Switch the rows and the column. Boom. Now this 2 is removed. We have 4 here. But now what? Now, hey, I want to put 2 instead of this 4. But do we know where we store the 2? Yes, the 2 is in the temp variable. That's good. So we say that, hey, matrix of j and I equals the temp. And that's it. This function will transpose the matrix. Now we said step 2, we need to reverse, and now let's go back to the blackboard and explain how we will do this. But let's say here we want to reverse the rows of the matrix. Okay, let's go back to the blackboard. And now we said we want to reverse the order of the rows of the matrix. In order why? To have the final answer. Okay, let me draw a simple 2D matrix. This will have only 1 row and 4 columns. So 1, 2, 3, 4. And I want to reverse it. Now the best way in order to reverse something, you can have 2 pointers. One pointer will be at the start, one pointer will be at the end. Let me make them different colors so we can differentiate them. Okay, so we have a left pointer, we have a right pointer. We will flip the one with the 4, then we will increment this green one, decrement this pink one, flip the 2 and the 3, and we are done. Basically, the whole operation of the flipping will finish when this green arrow reaches the middle point. Because when you reach the middle point, all the elements would be flipped. And now if you continue like to going to the end, now you will start undoing things. No, when you reach the middle, you stop, we flipped everything. Now what is the middle of this? Well, we have 4 elements. 4 divided by 2 is 2. Here we have index 0, index 1, index 2. Basically, when the green arrow reaches 3, we will finish flipping. So let's see. This one is at, again, this is a 2D matrix. This one is at index 0, 0. Okay? And I want to put 4 inside of this one. And I want to put the 1 instead of the 4. So again, we are losing elements. I don't want that. I want, again, a temp variable. So before I lose this one, we make temp, and this temp variable will hold the 1. Now I don't care what happens to the 1, I already saved it. This one is at index 0, 0. The 4 is at index 0, 3. So what is the formula that we are doing here? We can say, hey, the element at index I and j will be flipped with the element at index what? Let's think about this. Now we know we are in the same row, so the I will stay constant, but the column is changing. Now what is, oh, this should be, I and j, so I, j. So now what should we put here? Let's think about this. What we can do is that we can say, hey, we have 4 columns, right? So we can say 4 minus what? 4 minus 1. We know that the number of columns are 4, but the arrays are 0 indexed. So here we have 0, 1, 2, 3. The columns are indexed from 0 to 3. So we say, okay, take the last column at index 4 minus 1 and put it here. So now we will have, 0 and 3 as we have here. This will work only for the first element. Why I say that? Let's look. Let's say we flip the 1 and the 4. Good. Here we have the 1. And, here we have the 4. And here we have the 1. And it's time to increment this green pointer, as we said, and decrement the pink pointer. And we are here. We want to flip the 2 and the 3. Now what? Now the 2 is at index 0, 1. Now the 3 is at index 0, 2. Now if we use the same thing, the number of columns minus 1, we will keep getting 3 and 3 and 3 again and again. We don't want that. So what should we do? Well, look at this. The j started at index 0. Now the j is going to index 1. Okay. So the j is changing. We also need to account for the changing of j here. So what we can do is that we can say, okay, same thing, the number of columns, the minus 1, but we also need to subtract something else. Here the j is increasing, green arrow is increasing, but this one is decreasing, so we need to, to offset that change. So n minus j minus 1 should be the formula here, n minus j minus 1. Now look at this. N, we know we have 4 columns. 4 minus 1 gives you 3. But now 1. The j increased by 1. We need to account for that change. So decrease the j by 1. We have 4 minus 1 minus 1. 4 minus 1 is 3. 3 minus 1 gives you that 2. Now this formula will account for the changing in j, and we are all good. Now we will flip the 2 and the 3. Let's do that. So this will become a 3, and this will become a 2. And now we increment the green arrow and we decrement the pink one. So the green will become here, and the pink will become here. What do you notice? We said when the green one reaches the middle point, we break. And yes, indeed, it reached the middle point. 0, 1, 2, 3. The indices, we have index 0, index 1, index 2, index 3. We have 4 columns. 4 divided by 2 is 2, which means the middle point. And we reached it, and we stop. And indeed, we have 4, 3, 2, 1. We reverse the whole thing. We will do the exact same thing here. This one will be switched to 7, 4, 1. This one will be 8, 5, 2. And this one will be 9, 6, 3. We will do this approach for each row. As you can see, the I will start at 0, the I will go to 1, the I will go to 2, and this formula is the same. The number of columns minus 1 minus the change in the j as we discussed. And what do you see? This and this are the same, and we reached the final answer. So let's go code the reverse function and let's finish off this problem. We have again 2 for loops. So we will have for int I equals 0, same thing, I is less than the length I plus plus, okay, because we are going through all the rows, the row 0, row 1, and row 2. For instance, in this case, we will go through row 0, row 1, row 2. Now the columns for int j equals 0, we will start at the first, we will start at the first column. We will have a pointer here and the pointer here. So we are starting here. But now what? J is less than what? We said we only want to go to the half point, right? That's it, only to the half point. So we say, okay, we will go to length divided by 2, literally the half point, J plus plus. Okay, now imagine we are at the 1. We want to put 3 here and we want to put the 1 here. But again, I do not want to lose the 1. So make a temp variable for it. So int temp equals the matrix of I and j. Imagine we are in the first row, first column. I want to store that one somewhere. I do not want to lose it. Okay, and we said, so matrix of I and j will equals to what? We just discussed the formula. We said we need matrix of I and what? We said, hey, the number of columns minus the change in the j minus 1. So we know the length minus, we said something, and here we have the 1, and inside we accounted for the change in j. So the length minus j minus 1. Now we put the 3 inside of the 1, but do not forget to also put the 1 instead of the 3. So let's take this, which means now we will go to the 3. Hey 3, I don't need you, I want the 1 instead of you, and we are storing the 1 inside of temp. So that's it. Let's run the code and let's submit. As you can see, faster than 100%. Okay, so let's look at the time and space complexity. Well, as the question wanted, we did everything in place. So the space is constant, big O of 1. And we have a 2D array. We loop through all the numbers of the array, right? And we have, a square matrix n by n. So the time complexity would be big O of n times n, which means big O of n squared. Thank you guys for watching. Best of luck to you, and I will see you in the next one.